Okay, so today, this is going to be our last day of information for week 3. So after today's lesson, after the topics I go over today, you should be good to finish up the web quest. Okay, I've been very careful to make sure that I'm addressing all of the questions within this week's web quest. So I'm going to share the web quest right now, just to make sure everyone knows kind of where we are and where we should be. Awesome, everyone can see this. So on Monday, we talked about air masses. We talked about the types of air masses. We talked about the abbreviations for air masses and what those abbreviations mean. We kind of went over a map and determined what kind of air mass would form in different locations, depending on if it was formed over land or over water or up by Canada or down by Mexico, right? Those are all different places, so we're going to get different air masses. So we talked about that stuff on Monday. Yesterday, we talked about global wind patterns, right? How does the air move around the Earth? And kind of how do we describe it? What are the patterns that we see? And we talked about these global wind belts. So look at these global wind belts. What are the names of these wind belts? You can find this on this website right here. What's the jet stream? How fast does it move? Right? We see that kind of stuff. And then the Coriolis effect. So what's the Coriolis effect? What direction does the wind move? It turns in the northern hemisphere, right? Air doesn't go in a straight line. Air actually curves to the right up here in the northern hemisphere. Okay, and then down in the southern hemisphere, because everything's opposite, it curves to the left. Okay, so we talked about the Coriolis effect. We watched that video of those really tall, nerdy grad students throwing the ball at each other, but they were missing because they were on the merry-go-round and they were rotating, just like the Earth is rotating. Okay, so even though the merry-go-round is a small structure, it behaves in much the same way as the Earth does because the Earth also rotates. Okay, so we watched that video, and now what we're going to talk about today is really we're going to finish this up. Right, we're going to talk about pressure. We're going to talk about why clouds form. We're going to talk about cold fronts, and we're going to talk about warm fronts. And that's going to take you up through question 27. Question 28 is just a review quiz. Just take it. Tell me how many questions you got, right? Just take it. That's not going to be the graded part of this, right? I want you to take the quiz, but I'm not going to take that score from the quiz and do anything with it, right? I just want to make sure that you took the quiz and just be honest about how many you got right and how many you got wrong, okay? So that's it. After today, we're good. Tomorrow is going to be a work day, so I'm going to be on here helping you out if you need help with this week's web quest, with last week's project if you still haven't submitted it, with the first week's projects if you still haven't submitted those. I'm going to be on here tomorrow at 11 to help you if you need any help with those. Okay? So that's kind of the overview. That's like looking forward for the rest of the week. Okay. All right. So today's Wednesday. Happy Wednesday, everybody. Already July 21st. I'm not sure how that happened. So the agenda for today, we're going to follow along. Yeah, if you are following along with us, you should be done with questions 1 through 16 of your web quest. We've gone through all of that information. I just talked about that. Today, we're going to be going over the topics related to questions 17 through 27. And that's going to be pressure and clouds and cold front and warm fronts. Okay. I know there's 2 other types of fronts. There's stationary fronts and included fronts. We're not talking about those. Don't worry about it. Okay, it's summer. We're just doing the minimum here. Okay, wind and air pressure. What is wind? All right, you're outside, you're feeling wind. It's blowing in your face. But what is it? What's blowing in your face? It's air, right? All wind is air that's moving. Okay, so all wind is moving air. So how do we move air? How do we get air from one place to another place? Okay, and the way that happens, it happens very naturally, just like if you were to spill some water on the ground. it's going to go to the lowest point, okay? But here we're not talking about elevation. We're not talking about a hill or anything. It's going from areas of high pressure to areas of low pressure. Always. It always goes from high pressure to low pressure. So what we see here, we got this high pressure system, which we're going to talk about in a minute. We have this low pressure system, which we're going to talk about in a minute. Air is always going to move from this high pressure system to this low pressure system. Always. Okay, it's never going to go from low pressure to high pressure. Always going to go from high to low. Okay, that's a question on your web quest. Okay, so how are high and low pressure systems different from each other? Okay, if we are under a high pressure system, there will be clear skies. It's going to be beautiful out. There's no clouds, there's no rain, there's no fog. High pressure systems, if you're looking at a weather map and you see that big blue H, that's good. That's good stuff. That's going to be good weather. Okay. Like I said earlier, with that high pressure system, the wind is always going to move away from the high. Okay. It's never going to come in towards the center of that H, right? The wind is always going to be moving away from that H. Okay. And remember, because the Coriolis effect, winds don't go straight, right? The Earth is rotating, so the winds are curving. And around a high pressure system, those winds are going to curve clockwise. Okay? Those winds are going clockwise. So they're going away from the H and in a clockwise direction. Okay? Opposite that, we have low pressure systems. In a low pressure system, there will be clouds, right? High pressure system, no clouds. Low pressure system, lots of clouds, okay? You will also often get rain, snow, some kind of precipitation, and it will be cloudy, right? That's where the rain is coming from, okay? So basically the exact opposite of the high pressure. High pressure, beautiful weather. Low pressure, kind of crappy weather, right? Unless you love rain, which some people do. It's going to be cloudy, it's going to be rainy, okay? Just like, well, opposite the high pressure, the wind is not going away from the low, it's coming into the low. The low almost acts like a vacuum cleaner. Right? A vacuum cleaner is a low pressure system, okay? That's why it sucks everything into it, because it is a low pressure system. Okay, so the winds are moving towards the center of that low. Oh, that's a typo there. That should say low. So the winds are moving inwards towards the center of that low. And again, because the Earth is rotating, things don't move in a straight line, they're going to spiral counterclockwise. So they're going to go the opposite direction. More than anything. Okay, so what that's going to look like is here we got a map. We got a high pressure system over here over Utah and Colorado. We got a low pressure system over here over Kentucky. I think that's Kentucky. Okay, and what we see is here's this high pressure system. Those winds are moving away from the high, right? They're moving away, but they're not going in a straight line. They're rotating clockwise, the direction that a clock moves. So if you're watching a clock, if you have a watch, it's the direction that the hands move on a clock, okay? So in this high, that wind is moving away from the high and it's rotating clockwise, okay? Opposite that, we have our low pressure system here, which is a vacuum cleaner. It's sucking everything up, okay? So all that wind is going towards the center of that low and the winds are rotating counterclockwise, okay? So why do clouds form? Why do we get clouds at low pressure, but not at high pressure? Okay. And the reason for that, this is just the definition for why clouds form. But basically what happens is that air rises, it cools because the pressure decreases. So as air rises up into the atmosphere, it gets cold up there. Okay. The reason why it's cold up there is because the pressure is low. Okay. So the pressure is low, it gets cold. Okay. And the air now is going to expand, right? because there's lower pressure, there's more space for it up there. So the air is going to expand, okay? As it's rising, as it's expanding, as it's cooling down, it's going to cool down to its dew point, okay? And once it hits that dew point, you get clouds, right? Dew is just liquid water that's in the sky, okay? So once it hits that dew point, all of the water vapor inside of the air immediately is just going to become liquid water suspended up in the sky. And that's what we see as clouds. Okay? So here, kind of what we see in this diagram here is here's our temperature, here's our dew point. Our temperature is 92 degrees, which it might be 92 degrees today. And the dew point is 60. Okay? You can also tell that that mass of air is this size. It's actually kind of small. As it starts rising up, we're now at 3,000 feet, the temperature has dropped. It is now 76 degrees, right? Remember, as you go up into the sky, as you climb a mountain, it's gonna get cold, okay? So the temperature is decreasing, dew point's staying the same, it's still 60 degrees, but our mass of air has gotten bigger, right? Because as it's going up, there's less pressure, so that air is allowed to expand a little bit, okay? And then as we get up even higher to 6,000 feet, our temperature is now 60 degrees. Our dew point is 60 degrees. Now we get clouds, right? All the water vapor that was in this box comes out of the air. And now we have little droplets of water that are floating up in the sky, okay? And again, you can also see that this box of air has gotten bigger because there's less pressure, so it's able to expand a little bit. Okay, so this is our cold front. It's kind of like a bubble of cold air, and it's moving in this direction. Okay, because this cold front is moving in this direction, there's warm air in front of it. This cold front is like a bulldozer. It's just going to plow right through that warm air. Remember, cold air is more dense. Cold things are more dense. So you can kind of think of it as being more powerful. So this cold air is kind of plowing like a bulldozer right into this warm air, and the warm air is going to rise up over that cold air. Okay. And again, what we just learned about clouds is that as a parcel, as a box of air moves up into the atmosphere, it expands, it gets colder, and we get clouds. So here what we see is that this warm air is moving up over this cold air. It's going to expand, it's going to get cooler, and we're going to get clouds. So here we get clouds forming right here on the top of our cold front because the warm air that was in front of it is being pushed up, expanding, cooling down, and we get cloud formation. Okay, so a cold front is where we have cold, dense air that moves in and pushes the warm air out of the way. So that's what we see here. We have this cold, dense air pushing into this warm air and just being a bully, saying, hey, get out of my way. Okay? Cold fronts move quick, and they bring a short period of a rainstorm or a thunderstorm. So we're not talking like a week-long monsoon or anything crazy like that, but it is a very quick, very short, rapid rain event. Okay. Behind the front, we get lower temperatures. So right here, we have warm air in front of the front, and behind the front, we have cold air. Okay. And you're going to see these little symbols. They kind of look like little icicles because it's cold. The direction that those icicles are pointing is the direction the front is moving. So here in this example, here we have that line with those little icicles. Our front is moving in this direction. Okay, that's our cold front. Our warm front is again very similar. One more thing, a cold front is curved. Curve starts with C, cold starts with C. So it looks curved. It's like a bubble of air that's just like sitting on the surface, but it is a curved bubble. Okay. Here's our warm front. Kind of looks like a wedge. All right. So here we got that wedge. It's got that slope shape. Wedge starts with W. warm, starts with W. And again, we have something very similar, but instead of the cold front going towards it, we got the warm front moving faster than that cold air. So here we have that warm air. It's moving and it's kind of squeezing out that cold air. Think of this wedge here as like a roll of toothpaste, a tube of toothpaste, right? And what that warm air is doing is it's pinching the end so that all of that toothpaste can be forced out of the front. Okay, so here we have that warm air. It's kind of pinching and pushing that cold air in front of it. But remember, warm air is still less dense than cold air. So it's still going to be going on top of that cold air. So it's just slowly squeezing out that cold air, but it's still going to be rising above it. And then again, what we know about things that rise, they expand, they cool down, and because they cool down, we get cloud formation. Okay? So here we have this warm air rising, expanding, and cooling down. And that cooling down is going to create condensation, which is the process of water being made, right? It's the process of liquid water coming from a gas. Okay? So here is our warm front. Warm air moves up the cold air as it slowly displaces and overtakes the cold air. This is a slower process, right? This warm air is not a bulldozer. This warm air is not plowing wherever it wants to go. It takes some time because the warm air is less dense. You can think of it as being less powerful than the cold air. It takes a while to push that cold air out of the way. Okay? Warm fronts move slowly. Cold fronts move fast. Warm fronts are moving slowly. And these will bring us a couple of days of steady, light rain. We're not getting thunderstorms with this. It's just like steady drizzle over a couple of days. Okay? Behind the front, we get warm temperatures. That's why it's called a warm front. And the direction of these little circles, or often half moons, is the direction the front is moving. Now, I like to think of these as they kind of look like the sun. The sun is warm. This is a warm front. Okay, so our warm front is moving down here in this image. In this diagram here, the warm front is moving towards our right. Okay, that's it. That's everything. That's pressure, that is cold fronts, and that is warm fronts. Okay, so again, let's look at our web quest. So here's our web quest here, looking at where we are. Do clouds tend to be near high pressure or low pressure centers? We talked about that today. Okay, we talked about what makes clouds form, right? Why do they form at low pressure areas? And again, this is just click on this link here. Okay. So if you click on that link here, it's got all the information. And this isn't much, it's only a few sentences, but it talks about why we get clouds at high pressure and why we get clouds at cold pressure. Okay. What direction is a high pressure rotating? Is it clockwise or counterclockwise? We went over that. Same thing for low pressure. Number 19 and 20, just describe what you're looking at, what's happening, what are the motions, what's moving where, just describe that, okay? In both the cold front and the warm air rises and the cold air sinks. What is the property? Why does the warm air rise and the cold air sink? Think about week 1 if you're not sure. Okay, here we got cold fronts. What direction are they moving? What's the symbol that we use for cold fronts? Okay. What's the warm front? What's the symbol? What kind of weather do we get? There we go. And we got that, right? And then we got this little quiz. Again, take the quiz. Just tell me how many got right or how many got wrong. I'm not looking for 100%. Okay. So that is the project. That's the week. So if you've got any questions, if you're still not really sure, or if you got any specific questions about week 1 or week 2 or week 3, or general questions about week 1, week 2, or week 3, I'm going to stay on for a little while. If you want, you can go work on this web quest. You're done with this web quest. Okay, finish up those questions. You can submit this by this afternoon, and then you're free from Earth Science until next Monday. All right. So have a good afternoon. I'm going to be here taking any questions. So I'll see you tomorrow.